In this video, we'll be going over the memorization approach of edit distance. In the previous video, the recursive approach was very inefficient due to overlapping recursive calls, and we are going to optimize it using memorization, which means caching. Let's go over the thought process. So the recursive approach is inefficient due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. Now we'll ask ourselves, what do we need to cache? In each of the recursive call, we are trying to find the minimum number of operations, which we'll call OPS, at the current indices I and j. This means we can cache I and j with OPS, or the minimum number of operations. Now let's go over the pseudocode. So we're going to create a 2D matrix. So we're going to create a 2D matrix memo to cache previously calculated results, or we can say to cache the minimum number of operations, or we can say we can cache I and j with OPS. So the rows represents I, the columns represents j, and the values represent OPS. Then we can implement the top-down memorization approach. The parameters, we need to add our cache to our parameters list. And what's the base case? If memo ij is not equal to 0, this means we have already calculated the results for I and j, so we can just return memo ij. Now for this one, we're going to put the recursive results of moving both pointers forward at memo, and then we can return memo. This means caching it, and then we're going to put the minimum number of operations of the three types of operations inside memo, and then which means caching it, so we can return memo ij. Now what's the time and space complexity? So the time complexity is O of m times n, or mn, where mn are the lengths of the two input strings. This is because there are m times n possible states in our recursive calls. Now let's go over space complexity. Space complexity is m plus mn plus O of m plus n, which would default to mn. This is for the memo matrix. And m plus n is our recursive call stack memory. Now let's go over the code. So we're going to first prepare memo. If memo ij is not equal to 0, this means we have already calculated the result for ij, and we can return memo ij. Now before we return the minimum distance of moving both pointers forward, we want to cache it. And also here too, we will want to cache it. Let me know if any questions in the comment section below. In the next video, we'll be going over the bottom-up 2D matrix approach of edit distance.